Okay, now we're going to dip lightly into the mathematics of all this, which have largely been determined and formulated by Walter Schauberger. Walter Schauberger was a physicist and a mathematician, and when his father died, he agreed, or he promised his father, that he would try and develop a system of physics and mathematics which would explain Victor's theories in a way which was irrefutable, so that it could never again be said that Victor Schauberger's machines didn't work or that his theories were invalid. And it was this task which Walter set himself upon the death of his father in 1958, at the time when they came back from the United States. Walter Schauberger's mathematical system is based on the harmonics of the monochord. This is an instrument which was used by the Pythagoreans in order to determine harmonic intervals on a resonating string. And these intervals can only be determined or only positioned at whole number divisions of the string, so that if you divide an open string 1 into a half, then you get the first octave. So just to the right and the left of this point, half position, you will not get a state of resonance. It only comes when you have done it exactly on the point divided by, where you've divided the string by 2. The same occurs when you divide it exactly on the point dividing the string by 3, in which case you get a sort of tripartite waveform which moves between the nodes of where the string is divided. When you divide it by 4, then of course you get the second octave. And so that any string of whatever kind would produce at once a series of overtones, which are the overtone series which rises from above them, and also in the same sense a series of undertones. And Pythagoras and the Pythagoreans made a study of these because it was important to determine the harmonics of things, because they saw the world as being the manifestation of qualities and harmonics or harmonies. And in fact, a student had to study or pluck upon a monochord for maybe a year or 2 years until he could hear 120 harmonics on the string. Now that means the harmonics will get to an extremely high level. This was then important in order to realize how, just before I continue that, actually, just to show you how this links up with the hyperbola we saw before. If I can put that to the side and put this on here, then you'll remember. Then you can see that the full length of the string is 1, which is from here to here. The half is there, and the third is there, and the fourth is there. So that in fact this whole hyperbola, it represents the division of a string into an infinite number of integral divisions, i.e. dividing by a whole number. And as it's infinite, so at the top of it, the quality, in the sense of quantity times quality, the quality is infinitely high, as is the vibration at the top. And this gives us some idea of how higher qualities and higher energies and higher vibrations become the controlling force. Because if we take, for instance, these vibrations at the bottom, we'll say they're 1, 2, 3 cycles per second, or 2, 3, 4, 6 cycles per second. In order to be able to resonate with more and more, and to be in harmony with more and more things, we have to raise our vibration so that what is the next higher vibration is in tune with all of these. So if we take the next higher vibration, for instance, as being these green ones, then the vibration of 30 cycles per second is directly harmonic with 2, 3, 5, 6, 10 and 15, all of which numbers will divide equally into 30. Or 12 would be 2, 3, 4 and 6, or 10 would be 2, 4, 40 would be 2, 4, 5, 8 and 10 and 20. But again, once again, these, in order to combine them into a harmonic whole, they need to be again associated to a higher number even than themselves. So a number 120 would be the number in which to all these various numbers 1, 6, 10, 12, 15, 20, 13, 40 are all can all divide into equally, so that we come back to what I said earlier on about energy, about the higher energies being the formative energies. And when we look at this vibrating plate, we can see again how vibration creates a particular form. Here is a square plate with sand just sprinkled over it. The vibration is started and gradually the final form arises. And when that vibration is doubled, or when the next octave happens, then, as is shown in here, which is a different pattern, then the pattern becomes more complex. So here we have the first, what you might call the bass tone. There is the first octave, there is the second octave, and there is the fourth octave. Again, the complexity increases as the vibration rises, but the form still has the same fundamental characteristics. And it seems to me that all physical manifestation is based on states of resonance, and these are very critical and they're very precise. As we saw with those sand plates, a particular frequency produces a particular phenomenon. And therefore, if we want to arrive at phenomena, or if we want to recreate phenomena, then we need to arrive at those frequencies which are conducive to its formation. Unfortunately, the way most large numbers are handled, and here we are dealing with large numbers, is done using scientific notation, where a number is written as, let's say, 2.5 times 10 to the power of 26 or something like that, which means that it's the number 2 and then the number 5 and 25 zeros coming after it. And if you were trying to seek a particular level of resonance, you would need to know exactly what the last digit of all those 26 digits after the decimal place were. And this is what gets lost out. This is what we lose with scientific notation. On the other hand, with computers today, there should be no problem in determining a frequency value up to the 20th and 32nd place of decimals in order to find precisely that frequency which would, from which a particular form could evolve. Interestingly enough, also, that if we're looking at resonance, then this is. Wait a minute, I'm going to sit there. Stay. Good boy. These are some figures that I just came to me slowly as I was doing all my research. And it seems that the number 29 or 2.9 or various forms of it seem to have a peculiar coincidence with planetary phenomena. The speed of light is 299.7 kilometers per second. The Earth's natural resonant frequency is 29.97. The mean diameter of the Earth's orbit is 299.1 million kilometers. The Earth's mean orbital velocity is 29.79 kilometers per second. The length of the lunar or synodic month is 29.5 days. Saturn's orbital period is 29.46 years, and so on and so on. So the number 29 seems very strange number, and associated with the Earth. We discussed earlier also the geometries, and this actually puts them more under the limelight, because this section we're actually dealing with the mathematics. Now, this compares the two geometries, the non-Euclidean and the Euclidean. Nicht-Euklidisch is non-Euclidean, Euklidisch is the Euclidean system. Here we have the circle, the straight line, the point, the radius. And here these shapes are shapes. These ovals or these ellipses are taken as sections through a cylinder, taken through a right-angled cone, which means a cone where the shape is actually a right angle and it's circular this way. Any inclined section through a cone will also produce an ellipse. So all these are the elements of our technical world. So the circle, the straight line and point are all part of the same element, in fact. The circle has a certain radius. If I reduce the radius to 0, then the curvature is infinite and I have the condition of the point. If I increase the radius to infinity, then I have a position where the curvature is 0 and I have the straight line. So the straight line, the circle and the point are all aspects of the one element of the circle. But the circle and the straight line and point do not exist anywhere in the physical universe. They are of the mind. They are transcendental. They belong to the realm of measurement between things. They belong to the realm of thought, excuse me, but they do not belong to the physical world, because we cannot describe natural artifacts using those particular elements. The ellipse belongs in these systems because the ellipse is in fact an extended circle. It's like taking the center of the circle and dividing it in two and pulling it out, and then you get an ellipse from it. So they are all closed systems. They are all perfect. They cannot be varied, because a circle is a line of constant curvature, no thickness. A straight line is a straight line. A straight line means there's no variation. There's no movement about it. It's totally perfect, and it therefore cannot reflect any system in which change is inherent. Like in nature, change is inherent. There has to be constant change and transformation. And so this is represented by non-Euclidean geometry. And this is the geometry of nature. Using this geometry, then we can draw what is the first development from the formula which I showed you before, which had the hyperbola on it. That was the elevation of this spiral form. Now the spiral form, where we were looking at it on the hyperbola, was the distance 1 from there to the center. So it's actually very small. Clear. We will have a larger spiral at the moment. But this spiral starts at alpha, or alpha infinity, as Walter Schauberger called it, which is the beginning, and by rotating an almost infinite number of times, or an infinite number of times, seeks always to strive to reach the point, which is omega. So it's moving from the straight line to the point. And this is the curvature of matter, of the descent into matter. And the nature of this particular curve is such that no two parts of it are identical. And so within this also is underwritten not only the discontinuous aspect of evolution, which is the production of individuals, of individual things, but also the continuous movement of evolution into states of higher and higher order. So along this line, this spiral line, every part of it, the curvature is different. You cannot take a part out here and put in here. It doesn't fit anymore. And so every individuality, all the myriads of atoms, every single thing that exists in this universe can, in a sense, be represented by a small part of the spiral as its characteristic, because there are no two parts of it alike. As you progress towards the center, of course, the velocity increases, the energetic activity increases, and you get closer and closer to God, so to speak, because originally Walter called this the theocentric system, where God lay at the center. And the only way, in fact, to reach him was to jump out of space and time. So the curve, as it were, is space-time continuum. The straight line is out of space and time, and so is the point out of space and time. But there are the two bridgeheads from which life springs into physical existence. Interestingly enough, also, this spiral connects the points of the triangle, the square, the pentagon, the hexagon, the heptagon, the octagon, the nonagon, the decagon, etc., 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 etc. And one of the amazing things about this is you begin to learn how nature can divide things up with equal angles. If I can find the thing. Where is it? No, this is what's getting out of context. Just to show you how this form is also, this hyperbolic spiral appears in nature. This is a meteosat photograph. Here you have the diagram I showed you before, and this is virtually the same energetic wall. This is a low pressure system, and again, it's like the tornado. The energy, the closer you get to the core, the greater the energetic content. Again, the same math can be used to explain galaxies. You can have a galaxy much the same as this, and also as I overlaid that galaxy earlier on in the show. Into this too are all the various this hyperbolic cone again can be used to explain all the different frequencies, from ultraviolet, visible light, infrared, radar, and so on, all as questions of wavelength, of distance from the central axis to the outside edge of the hyperbola. If we move in now on the spiral, we can, to go to a closer view of it, we have made, so to speak, one full revolution from alpha, which is infinite distance away there, and we've gone round completely once. We've turned round through 360 degrees, and we arrive at the value of 1, because we have made one total revolution. And at that point, we can say that the string length, so to speak, is 1. We have completed the period of what you might call pregnancy, because before 1 there is nothing. There is no wholeness before we arrive at the 1. And after that, then we enter the world of the physical world. Before that is still transcendental, and from this point 1 onwards, there has become an individuality. Before an individuality, there is only energy. And with a string length 1, after one full revolution, we have moved into a position of a half, into a third, into a quarter, into a fifth and sixth. Exactly the same in reflection of the hyperbola which went up in the other direction. So here we would have the distance 1, there would be 2, so the elevation of this would be a curve which goes up in the opposite, in the other dimension. And into this can also be interpreted musically, because the string length being 1 would have a certain tension, and then as we reduced the length of it, the tension would give rise to all the various notes that we are aware of, and it would be just wherever the string length is, gives you whatever the note is, so to speak. And then you find some interesting relationships that in the major notes on the scale, they are always divided by multiples of 15, 30 degrees, 60 degrees between F and G, and so on. And the other half notes are multiples of 3 or 9. So one begins to get certain insights into the patterns of energy by looking it through the spiral form. This is also another one which interprets in terms of color, that you start with the base tone where you've got the rather darker color. As you move around, then the color becomes a higher frequency, so that it's a lighter color, but still going through the full spectrum, so that it begins to teach you how eventually all colors return to the source from which they came, which was white. And also an idea of the higher vibrations of colors that, for instance, clairvoyants and other sensitives are aware of, which are really merely harmonics of the lower ones. This spiral that we saw before is also the spiral by which you can use to divide any angle into any equal parts, any number of equal parts. Now, if you've looked at a pineapple, you've seen that it has spirals on it, maybe 13 going one way and 34 going the other way, or on a pine cone, there's 5 going one way and there's 8 going the other way. So how does nature make these beautiful divisions? Because 13, to divide 360 degrees by 13 is a bit difficult, or by 24, or by 33. But if you take this hyperbolic spiral and you want to divide an angle, let's say this angle AB, then you take your compass, you make a mark at the top and the bottom where you want to incorporating the angle, and then with that radius you multiply that radius 5 times if you want to divide that angle by 5. And once you've multiplied the radius 5 times, then you have this length here, the green one, which then has the value of 1. And you draw an arc from the center to where it cuts the hyperbolic spiral, and you draw a line to the center. Then you reduce the radius to a half, and you do the same, and then you take it to a third, and the same, and a quarter, and do the same, and finally to a fifth, and you divided that angle into 5. And here again is the hyperbola when you connect all those lines together. So it's a kind of mathematics which seems to be very integrated. If you take a section through the hyperbolic cone, then you can get fish shape. This is the hyperbolic cone, part of it there and part of it here. And taking an angled section through it, the flat plane that you can see would have this form. And there's a bit of the tail of the fish too. If you cut it in another section, slightly flatter, then the egg can be obtained from that. So with this system, it's possible to create any egg precisely and mathematically to determine it. You can design your own egg, so to speak, the one which is most suited to whatever purpose you require. And according to Walter, maybe it was even in the shape of the egg itself that the flight characteristics of the different birds were, because one kernel of curvature produced one form, a different curvature on the egg produced a different kind of bird. I don't know if anyone has really made an accurate study of the precise dimensions, but they're all different sizes of egg, and all the birds have different flight characteristics. And so in using this process, I've actually been able to make some eggs. These ones hold about, I think it holds about 5 gallons or something. It was made as a water device. And this shows you a little bit more how you can make sections through these cones. These are various sections taken through the cone, and from these you get a number of different egg shapes. This one, for instance, would be taken. It's difficult to do this without relation to the cone. I'll try and put that back here. No, I think I'm going to take it out. It depends how pointed the egg is, depends on how steeply you make the cut through the cone. And it doesn't matter where you make the cut on the thing, you can always define it from a mathematical point of view. These are all different egg shapes. And these are the data which correspond to it, so that it does show you that they can be very precisely defined. It's a different one. I'm afraid it went slightly wonky at the end. And there's another one which is more leaf-shaped. So all these can be drawn out of Walter Schauberger's maths, which again is this very simple form of maths based on the equation 1 over n times n equals 1. And I think probably there's just one more point that I would like to make, and to show how this relates to the orbits of the planets. This is the same sort of section that we had before, where there are various sections taken through the cone. Now these ones correspond to the planets themselves. I did this one deliberately to find them, and so this orbit here is the orbit of Mercury. Now we say egg-shaped orbits, and actually it's the inside one is egg-shaped. The outside one is the corresponding shape of an ellipse, using the same eccentricity, as it's called. There's one focus and there's the other focus if this were ellipse. If this is an egg, there's only one focus, which is here, and that concerns the inner line. Now if you were trying to find the planet, in this particular instance, this being Mercury, there's a variation of something like 4.8 million kilometers between here and here. So if you were trying to land a spaceship on Mercury and you were using Euclidean geometry, you could be quite a long way away. And I do believe that when they tried to land one of the landings on the moon wasn't where it was, and they had to use up quite a lot of fuel in order to actually get there. And the thing may have been the result of this discrepancy, that the moon they thought was here, but it actually was here because it was following an egg-shaped orbit rather than an elliptical orbit. And these planets then they also interestingly, they also follow a line, a hyperbola, where you have the orbital velocity times the distance from the Sun, and those create a constant, and so you can plot very easily where all the planets lie on this hyperbola. So the mathematics of Walter Schauberger and his father's processes, which are always these reciprocal things which end up in the unity, or they show how that energy can be created, or the paths that energy wants to move in, are very much integrated. And I think they really need to be brought into focus for a new direction in technology, a new direction in environmental treatment, a new direction in water resources management, forestry. In fact, a new direction in almost any avenue of human endeavor that you can think of, because we seem to be doing it wrong. If we were doing it right, we wouldn't have the problems we have today. And it seems to me that Victor Schauberger and Walter Schauberger have some way, they're not the whole solution, but they have got part of the solution at least, which allow us to understand how we can change the environment, how we can restore the climate to a state of balance, how we can do so many things to improve agriculture so that we can have far more people alive on this planet, but fed well, housed well, all those things. If some of the information, or perhaps all of the information which Victor Schauberger has to offer, can finally be integrated into a different society. Victor had one thing to say, and I quote him. Firstly, well, two things. First is, if you want to know what the right thing to do is, do exactly the opposite. You must comprehend and copy nature. And then one quotation from him, which I think is very telling. He says, "They call me deranged. The hope is that they are right. For it matters, it's of little import if yet one more fool should wander this earth. But if I am right and science is wrong, then may the Lord God have mercy on mankind." And he wrote that in 1930, after seeing what would inevitably happen if all the various technical processes we set in motion continued unchanged. And that is exactly where we have got today. In 1930 he forecast all the environmental problems we are having today, and he said exactly why. So I think that's where I shall bring this to an end.